A3 is solving multiple variable linear equations or systems. Multivariable.
Thank you.
Okay? Meaning you have an x, y, and a z.
It's called a Z.
Oh, what is that? Is that V8?
You just tried like 5 times.
I had two
No,
dollars.
we were in
Thank you very much.
It's a Z.
Maybe the long one counted as two, so maybe three.
Okay.
Do what? They acted like that's not.
Yeah, I'm talking about the pass.
I got you.
I hit off the box. Okay. So we are going to have systems of linear equations that we are solving with three variables. We'll start with, we'll start with an easy one. We'll start with x minus 2y plus 3z equals 9. And then we'll have y plus 4z equals 7. And then we'll have simply z equals 2. On this one, this is very simple. I would start with the equation of z equals 2 and plug it into the red equation so I can solve for y, and then take y and z and plug it in to solve for x.
That's crazy.
That's gonna, this is gonna be the easiest one you do.
Oh God.
So,
On God.
we're gonna say y plus 4 times 2 equals 7, which means I get y plus 8 equals 7, which means y equals negative 1.
Wait, where did you put the X?
Guys,
Fell.
get up.
Wow.
There is no x in this equation, there was only a y and a z.
Wait, so it's different equations like that?
Yeah, 1, 2, 3. I made 3 different equations.
Someone help the bring the walking around, y'all. In the first one.
Stop and listen. Focus. Because you're not going to know how to do this.
This jacket is.
And this is going to take you a long time. Dakota, shut up. There's only an x in this equation. The other two don't have it.
Oh, they're 3 different equations.
3 different equations. That's why I wrote them in 3 different colors. Okay, so the first thing I do is I plug 2 in to this equation so I can solve for y. So now I have y and z. So what I'm going to do is plug y and z into the black equation so I can get what x is. So I have x minus 2 times negative 1 plus 3 times 2, okay, equals 9. I get x plus 2 plus 6 equals 9. X equals 1. When you write this system of points, when you write these points in a system, you're going to go x, y, z. So I say 1, negative 1, 2 is my solution. X, y, z. That's the order you have to write it in. 1, negative 1, and 2. Let's try a much harder one. And you're going to have to probably do substitution and elimination on a bunch of things. Okay. Let's do this one. We're going to do x minus 2y plus 3z. X minus 2y plus 3z equals 9. Then we're going to do negative x plus 3y plus z equals negative 2. And then we're going to do 2x minus 5y minus 5y plus 5z equals 17. Okay. Now, I notice that in the black and in the blue equation, what could cancel out?
The X's.
The x's. So I'm going to start with those two equations because they happen to be able to cancel out. So I'm going to say x minus 2y plus 3z equals 9. And I'm going to take negative x plus 3y plus z equals negative 2. I'm going to go ahead and add those together. When I add these, that cancels. What's negative 2 plus 3y?
Y.
Y. What's 3z plus z?
4Z.
And what is 9 plus negative 2?
7.
gonna pause there. We're gonna come back to that equation in a minute. Now, I need to take either the blue and the red equation and cancel out the x's, or the black and the red equation and cancel out the x's. If I were you, I would take the blue because it has a negative in front of the x. Okay, so you have less error of messing things up. And I'm going to take this equation, I'm going to multiply it by 2 so that it will cancel out. So you get negative 2x plus 3y plus, nope, I lied, plus 6y plus 2z equals negative 4. Because you distribute that 2 into all pieces. And then you have 2x minus 5y plus 5z equals 17. Now I'm going to simply add these equations together. Negative 2 and positive 2 is 0. What's 6y and negative 5y?
1,
What's 2z and 5z? And what is negative 4 and 17? 13. Now, I have an equation here, and I have an equation here with just a y and z. We're going to use those two equations. Luckily, these both have a leading coefficient of 1. So I'm literally only going to bring this equation over here, and I'm going to subtract it from the other one, like this. Don't forget that that gets in there. Y minus y is 0. 7z minus 4z is 3z. 13 minus 7 is what?
are you gonna pass them?
Divide by 3, and z is 2. Now, you take that z and you plug it back into one of these two equations. I'm just going to come over here and plug it in. So I have y plus 4 times 2 equals 7. So you have y plus 8 equals 7, and you get y equals negative 1. Now I have y and z. I'm going to plug y and z into any of my original equations. Doesn't matter which one, any of them will work. I'm going to stick with the top one because it's easy. And so the top one says x minus 2 times 1, negative 1, right? Plus 3 times 2 equals 9. So I get x plus 2 plus 6 equals 9. X plus 8 equals 9, so x equals 1. So my solution is 1, negative 1, 2. That also is a fairly easy one.
It's just a more complicated version of that one.
It is.
Have we done this before?
We have in Algebra 2.
It looked
And it's just like we did the last 2 days, except for we added a z in with it. Let's talk about one like this. Let's do x plus 3y plus z equals 1. No, x minus 3y plus z equals 1. And then we're going to do 2x minus y minus 2z. 2x minus y minus 2z equals 2. And then we're going to do x plus 2y minus 3z equals negative 1. Okay. Do we see anything that we can cancel out automatically? In which equations?
red and blue.
Red and blue. Okay. So x minus 3y plus z equals 1, and x plus 2y minus 3z equals negative 1. I'm simply going to subtract these equations from each other. When I subtract, I have x minus x, which is 0. Negative 3y minus 2y, which is negative 5y. Z minus negative 3z gives me positive 4z. And 1 minus negative 1 gives me 2. Now, I need to use one of these two equations to go with the black one, I'm just gonna use the blue one because it's right there. And I'm gonna say 2x minus y minus 2z equals 2. I'm gonna multiply this blue one by 2 as well, okay? So then I get 2x plus 4y minus 6z equals negative 2. We are going to subtract this from itself. That cancels out. Negative y minus 4y gives me negative 5y. Negative 2z minus 6z gives me positive 4z. 2 minus negative 2 gives me 0. Now, here, I'm going to use these two equations now. You get negative 5y plus 4z equals 2, and you have negative 5y plus 4z equals 0. Subtract them. Negative 5y minus negative 5y gives me 0. 4z minus 4z gives me 0. 2 minus 0 gives me 2. No solution. This is inconsistent. So it's no solution and inconsistent. Okay? These are the things you're working on your homework tonight. Stuff like this.
That's why.
How much money?